Python multiprocessing PicklingError, can't pickle. I am sorry that I can't reproduce the error with a simpler example, and my code is too complicated to post. If I run the program in IPython shell instead of the regular Python, things work out well. I looked up some previous notes on this problem. They were all caused by using pool to call function defined within a class function. But this is not the case for me. I would appreciate any help. Update: the function iPickle is defined at the top level of the module. Though it calls a function that contains a nested function, i.e., f calls g calls h, which has a nested function I, and I am calling pool.apply_async f, g, h are all defined at the top level. I tried simpler example with this pattern and it works though.
Here is a list of what can be pickled. In particular, functions are only pickleable if they are defined at the top level of a module. This piece of code yields an error almost identical to the one you posted. The problem is that the pool methods all use a mp.simpleq to pass tasks to the worker processes. Everything that goes through the mp.simpleq must be pickable, and foo.work is not pickable since it is not defined at the top level of the module. It can be fixed by defining a function at the top level, which calls foo.work. Notice that foo is pickable, since foo is defined at the top level and foo._dict_ is pickable.
I use pathos.multiprocessing instead of multiprocessing. Pathos.multiprocessing is a fork of multiprocessing that uses DIL. DIL can serialize almost anything in Python, so you are able to send a lot more around in parallel. The Pathos fork also has the ability to work directly with multiple argument functions, as you need for class methods. Get Pathos, and if you like, DIL, here, this URL.
When this problem comes up with multiprocessing, a simple solution is to switch from pool to thread pool. This can be done with no change of code other than the import. This works because thread pool shares memory with the main thread. Rather than creating a new process, this means that pickling is not required. The downside to this method is that Python isn't the greatest language with handling threads. It uses something called the global interpreter lock to stay thread safe, which can slow down some use cases here. However, if you're primarily interacting with other systems, running HTTP commands, talking with a database, writing to file systems, then your code is likely not bound by CPU and won't take much of it. In fact, I've found when writing HTTP/HTTPS benchmarks that the threaded model used here has less overhead and delays. as the overhead from creating new processes is much higher than the overhead for creating new threads and the program was otherwise just waiting for HTTP responses. So if you're processing a ton of stuff in Python user space, this might not be the best method.
As others have said, multiprocessing can only transfer Python objects to worker processes which can be pickled. If you cannot reorganize your code as described by Unubu, you can use DIL's extended pickling/unpickling capabilities for transferring data, especially code data, as I show below. This solution requires only the installation of DIL and no other libraries as pathos.